children, let's discuss example 1.6. So read the question for the 1.6 children. So what is the question? Consider three charges Q1, Q2, Q3 each equal to Q at the vertices of an equilateral triangle of side L. Okay. What is the force on a charge capital Q? Okay. And what is the charge of the Q which they have given you? With the same sign as small q placed at the centroid of the triangle as shown in figure. Okay. So they have given you three charges. What are they? Q1, Q2 and Q3. Okay. And they are placed at the vertices of an equilateral triangle of side L. Okay, right? So this is the equilateral triangle. ABC is the equilateral triangle of side L, and the three charges are placed at the vertices of the equilateral triangle. What is they have asked you to calculate the force on capital Q. Okay, force on capital Q. And where is this capital Q? This capital Q charge is placed at the centroid of the triangle. Okay, right? So this point will be the centroid of the triangle. So let that point be O. Okay, right? So at the point O, we have placed another one charge capital Q, and this capital Q goes with the positive sign, same as that of the other three charges. So other three charges are of positive sign. So this capital Q is also of the positive sign only. Okay, right? So they have, now what are we going to do? We are going to calculate the total force on charge Q. Okay, right? So total force on charge Q, that's what we are going to find. Okay, children, right? So before finding the total force on capital Q, what we have to do is we have to find and write an expression for force on capital Q due to Q1. Okay, then we will be writing an expression for force on capital Q due to Q2 and force on capital Q due to Q3, and according to superposition principle we will add them together and we will find the force on capital Q altogether. Okay, so let's do one by one. So first of all, let me write the expression for force between Q1 and capital Q. Okay, and let me represent that force as F1. Okay, F1. Okay, so what is F1? F1 is the force between Q1 and capital Q. Okay, as they both are positive charges, you know that this Q1 will be repelling the capital Q. So the force due to Q1 will be along this direction. Okay, so this one will be your F1 vector. Okay, right? Now let me write the magnitude for this F1 vector. So this F1 vector sorry children, according to Coulomb's law will be 1 by 4 pi epsilon naught. Okay, then the product between the charges. Am I right? What is the general formula for Coulomb's law, children? Hope you remember. F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. If I write the vector form, then R unit cap. This is the general formula for your Coulomb's law. So now if we write an expression according to the general formula, F1 vector will be equal to 1 by 4 pi epsilon naught. Instead of Q1 Q2, I have Q1 Q and capital Q. Okay, so let me write Q capital Q divided by R square, right? What is R here? R is the distance between the two charges. So distance between A to this point O, right? So let me write that distance as AO square. Okay, and what is the direction of the force, children? This unit vector gives the direction, right? So what is the direction of unit vector here? It is along AO. So this is going to be AO unit cap. Okay, right? So this will be the expression for force on capital Q due to Q1. Similarly, what will be the force on capital Q due to Q2? Again, Q2 capital Q are here, right? The distance between them is BO. Let me write an expression 1 by 4 pi epsilon naught Q capital Q divided by BO, right? The distance between the two charges is BO here, BO square into BO unit cap, right? See, this Q2 charge again is positive, this is also positive. So this Q2 charge will repel this capital Q charge along this direction. So this will be the direction of your F2. Okay children, right? And it is along BO vector. Okay. Similarly, what will be the expression for force on capital Q due to the third charge, that is due to Q3 at the point O? That will be equal to 1 by 4 pi epsilon naught, again Q into capital Q, Q into capital Q divided by CO square, CO square, right? And the unit vector will be along CO unit cap. Okay. So see, this is also positive, this is also positive. This Q3 will repel this capital Q along this direction. So this is your F3. Okay, right? So this is your CO unit vector. Okay children, right? So first of all, what we have to do is, we have to find the value for AO, BO and CO. Let me do that by the side. Now see, this AO distance will be equal to BO distance will be equal to CO distance, right? Hope you agree with me. So from the diagram, we know that AO is equal to BO is equal to CO. Okay, the magnitude of the distances is going to be the same only. Okay children, right? Let's find the magnitude. Okay, right? So for finding that, now first of all, let me represent this point as AD. Let me write an expression for AD from the cosine value, right? So what will be cos of 30 degree, okay, from the triangle ADC, right? Where is the triangle ADC children? ADC, and which is the theta value here? 30 degree. 30 degree is this angle. Okay, right? So equilateral triangle, no? So this whole angle will be 60 degree. This centroid will be bisecting the angle. So as it is bisecting the angle, this angle is going to be 30 degree. So from the triangle ADC, cos 30 degree will be equal to cos, right? Cos means what? Adjacent side by hypotenuse, am I right? Which is the adjacent side here? AD is the adjacent side. So AD divided by, which is your hypotenuse? AC is your hypotenuse, opposite of 90 degree. So AC is your hypotenuse. Okay, we need AD, right? So therefore, what is AD is equal to? AD is equal to AC into cos of 30 degree. Okay, now what is this AC length? AC is equal to small l, right? So L into, what is the value of cos 30 children? That is equal to root 3 by 2. Okay, so thus we have found the value for AD. But we don't want AD, we need AO. So this, what is this AO? AO is the distance of the centroid from the vertex. Okay, right? And what's the formula? AO will be equal to 2 by 3 times AD. Okay, right? So this we have already studied in our lower classes. Okay, right? So this O is the centroid point, means this is the perpendicular bisector, means the AO distance will be equal to 2 by 3 times AD. Okay, so 2 by 3 times AD. So we have gotten value for AD. So into L into root 3 by 2. Now what will happen? 2 cancels off. So you will be getting L into root 3 by 3. So this 3 can be written as 3 this 3 can be written as root 3 into root 3. So one root 3 and another one root 3 will get cancelled off, and I will be getting L by root 3. Okay children, right? So now what is the value for AO? AO is equal to L by root 3. If AO is equal to L by root 3, then BO, CO will also be equal to L by root 3. So thus I can write AO is equal to, BO is equal to, CO is equal to L by root 3. Okay children, right? And what will be square of that? AO square will be equal to L square by 3, right? Root 3 the whole square will be just 3 alone, right? So this is going to be AO square, BO square and CO square, right? So now we have your AO square, BO square and CO square. So all these three equations can be rewritten by substituting this value. So let me rewrite them. So now let me number this as first equation, second equation and the third equation. So the first equation becomes equal to f1 vector is equal to 1 by 4 pi epsilon naught q into capital Q divided by AO square, right? Instead of AO square I have L square by 3. So L square, this 3 will go to the numerator. So 1 into 3, right? L square into AO unit cap. Okay, let this be the fourth equation for me. Similarly, your second equation will become equal to f2 vector is equal to 1 by 4 pi epsilon naught q capital Q divided by BO square. Now I have told you AO is equal to BO, so AO square will also be equal to BO square. So BO square will be L square into 3 into BO unit cap. Let this be the fifth equation. Then the third equation becomes equal to f3 vector is equal to 1 by 4 pi epsilon naught capital Q small q divided by CO square. Now CO is equal to L by root 3. So CO is equal to L by root 3. So CO square will be equal to L square by 3. So L square into 3 CO unit cap. Let this be the sixth equation. Okay. Now according to your superposition principle, okay, according to the superposition principle, the total force on the charge capital Q will be equal to vector sum of f1 vector plus f2 vector plus f3 vector. Okay, right? So see the fourth equation, fifth equation and the sixth equation, children. In all these three equations, this 1 by 4 pi epsilon naught capital Q small q capital Q L square into 3 is common. So let's take them out. So what can I write? I can write 3 divided by 4 pi epsilon naught small q capital Q divided by L square into what else will be remaining from the fourth equation? AO unit cap. What else will be remaining from the fifth equation? BO unit cap plus CO unit cap will be remaining. Okay, right? So see these three vectors, right? These three unit vectors, that is your AO vector plus BO vector plus CO vector, right? All these three vectors can be made to form a triangle. Okay, right? So let me draw it in the next page. So remember this equation. I will write it in the next page again. So I will write the expression for FQ first of all. So what is force on charge Q is equal to, children? 3 divided by 4 pi epsilon naught small q capital Q by L square. Small q capital Q divided by L square into, I have my AO unit cap plus BO unit cap plus CO unit cap. Okay, right? So now these three vectors, where are they? Where are they? See, A, O, okay, B, O and CO, right? So AO, BO and CO, right? They can be represented by the sides of a cyclic triangle. Okay, that is so AO vector, this is your BO vector, means this will be your CO unit vector. Okay, right? And if you note angle between all these three, right, that is your AO, right, all these three, that is, I will show you in the next page. The angle between all these three vectors will be equal to 120 degree. Okay, right? So each pair of unit vectors will be making 120 degree. So now I can consider that they are forming a cyclic vector, right? I can use here triangle law of cyclic vectors. Okay, right? So if I use a cyclic law, triangle of cyclic vectors, then what will I be getting? AO vector plus BO vector plus CO unit vector will be equal to 0. Okay, right? So this is your triangle law of cyclic vectors, right? If three unit vectors can be represented by the sides of a triangle like this, taken in a cyclic order, then the vector addition will be equal to 0. Okay, right? So if this addition, this summation is equal to 0, then the whole of FQ vector will become 3 divided by 4 pi epsilon naught small q capital Q divided by L square into 0. That is total force on the charge capital Q due to all the 3 individual charges, right? Total force on the capital Q due to all these 3 individual charges will be equal to 0. Okay, right? The net force will be equal to 0. Okay, children, right? So this is how we have to solve example number 1.6. Okay, children, right? Hope you have understood.